Okay. So, today, we're going to be working with data. As we are working with data, specifically we're working with what's known as bivariate data. Bivariate data. Bi means two, variate means variable. Bivariate data is a situation where you have two things that are going to be varying. And these two things that are going to be varying, we're going to refer to them as x's and y's. But unlike x's and y's in a true linear equation or in quadratic or exponential or absolute value or square root, whatever it might be, unlike those, in those situations, what you put into the equation directly leads you to what comes out when you have anything that can make an equation. In bivariate data, that is not the case. Bivariate data is ones where the two things that vary, while they might have some sort of a relationship, it's not a direct relationship. For example, how much homework you do and how well you do on tests and quizzes. Are they related to one another for most people? Yeah, if you get the practice, you're going to have better outcomes. But they're not directly related. There is no formula that says, well, if I do 3 hours of homework, I can guarantee an A+. Nah, it doesn't work that way. So there's a relationship between the two items, but they're not necessarily directly related. So when it comes to working with bivariate data, oftentimes one of the things we try to do with it is we try to graph it. And the graph of these makes what's known as a scatter plot. Because to graph bivariate data, all you're really going to have is a bunch of data points. This person spent 10 minutes on homework and they got a 58% on their test. So we would have the input of the coordinate point, 10 minutes, 58%, and things like that. It just creates a bunch of coordinate points for every individual data point. In that situation, every person's, how much time they worked on stuff and their score would each be 1 point on a graph. Now, when we're dealing with this, when we have a situation where there legitimately is a relationship between the two, it's called correlation. There is a shared relationship between them. Now, one of the things you have to be careful of with correlation is oftentimes people think correlation is directly causation, and those things are not true. Is there a relationship between how much time you practice on things and how well you do on tests and quizzes? Yes. But it's not always directly related. If I give you a really, really, really easy test, is studying for it automatically going to make your score go up? No. Because if it's really, really easy, in theory, everyone's probably going to do pretty darn well. So there's not that direct studying gives you score. Now, when it comes to correlations, there are different types of correlations. There is what's known as a positive correlation. Whereas one variable increases, the other one tends to increase as well. That would be like study time and test scores. Generally, as you study more, test scores do go up. If as one variable increases, the other one decreases, that's called negative correlation. There are a lot of things out there that also have a negative correlation, but that doesn't necessarily mean it's a bad thing just because it's negative. All it literally means is just that it has that relation as one goes up, the other one goes down. Things like education and poverty generally have a negative correlation. Generally, as you are more educated, the likelihood that you are going to be poor goes down. So they have what's considered a negative correlation. Not a bad thing, just the relationship that things go down. Essentially, if you looked at the scatter plots for a positive correlation, all of the dots are kind of going to do this thing where they increase. Well, a negative correlation is going to look like a bunch of dots going downwards. Now, it's also possible to have things that are not correlated at all. They have no correlation. Things that are just generally completely unrelated. How fast you drive on average to get to school and your test scores are probably not related. They would be a no correlation situation. And that, when you do that, just tends to be a bunch of random points on the graph. Because this person drives really fast, but they do really well. Well, this other person drives really fast and didn't do well. Now, when we're looking at these scatter plots, at these data points, generally speaking, one of the things we want to look at is we want to look at just how strongly two things are connected to one another. How strongly is it that you studying increases your test score is something that you often want to know. It gets more and more important as the data gets more and more important. Correlations like this are what tell us that smoking tends to lead to cancer. It's not a direct connection. Not everyone that smokes gets cancer. But they are highly correlated because of the fact that there is such a high percentage of it. And so to measure just how closely connected things are, we look at something known as a correlation coefficient. And it measures just how closely that data set specifically models a linear relationship. How closely it ends up kind of starting to look like a line. Now, this correlation coefficient is always going to be between -1 and 1. If that correlation coefficient, that R value, because that's what it's depicted by, if it is close to 1, it is a positive correlation. If it is close to -1, it's a negative correlation. And if it's near 0, that's kind of telling us that there's no correlation. Now, one of the things you essentially have to do with this R value, if you're going to tell you that, yeah, it works, no, it doesn't work, is you really just kind of have to look at how close to 1 or -1 it is. If you have a situation where an R value is only like 0.6, it's positive, but it's not particularly close to 1 when you're talking about the grand scheme of numbers only being between -1 and 1. So a correlation coefficient of 0.6, while it is a positive correlation, it's fairly weak. While on the other hand, a correlation coefficient of a -0.9 is really close to -1 and therefore is a strong negative correlation. So, when it comes to these correlations, when it comes to our scatter plots, these are examples of kind of what scatter plots look like. And you can kind of tell what the correlation is going to be based on them. This one right here. If I look at this, it looks like the data's kind of almost going in this linear line going in the positive direction. This is a strong positive correlation. In this case, our R value would probably be like 0.8, 0.9 because it's making that line. It's that linear relationship. This one here seems to be doing the same idea, but going in the negative direction. And this one's even stronger. But it's a strong negative correlation this time. This one's R value is probably smaller than negative 0.9. It's getting really close to that negative 1. If it forms a perfect linear line, then it will be either 1 or negative 1, depending on if it's increasing or decreasing. This one right here just looks like a bunch of random dots. That's no correlation. What appears to be happening here? It's kind of going positive, like you can kind of see it's going upwards because there's like nothing here-ish, nothing here-ish. But it's definitely not great. This is a very weak positive. Bordering on no correlation. In the situations where you have a very weak correlation out in the real world where two things are very weakly correlated, oftentimes there's something else involved that it might be closer in correlation with that just isn't being accounted for. And I wish I had a better example of what that was, but my brain is not coming up with an example of that. This one right here. It's negative, and it's either weak or moderate. I would kind of go with a moderate negative. It's kind of, you could tell it's going negative, but it's not great. The last one, are they kind of forming a line-ish or no? Kind of. Not great. This one's definitely a very weak negative. Again, a situation where it's almost no correlation at all. Especially with this few of data points. As you get more data points and you see a weak correlation, there's generally an argument that something's happening, you're just missing a piece of information. Now, do you notice on the ones that had a correlation on them, I kind of drew a line through the middle of them, like purposely showing kind of that linear relationship that's happening. And that is because, generally speaking, when things are correlated, we want to know just how correlated they are, so we make a linear equation that's not perfect to the data, but it gives us an idea of what we can expect. These linear equations that kind of go through the middle of the data, giving us some sort of a representation of what's happening, they're known as a line of fit. It's a line that approximates the linear relationship. Now you can make a line of fit by just kind of drawing a line as close through the middle of the data as you want and then writing an equation for it. How do you write an equation? You pick 2 points on it, you find the slope. You plug into point-slope form, you change it into slope-intercept form. It's what we've done a couple times already this chapter. Now there is a line of fit for just any line that kind of, to the best of our estimation, goes through the middle, but there's also one that's perfectly in the middle. It's called the line of best fit. The line of best fit is what our calculator is able to actually calculate. Our calculator can give us the best option. And so that's what we are going to be using to kind of make our line of fit. Is because if we're going to do a line of fit, why not do the best one possible? So, I got my graphing calculators. Now, if you have a TI 83 or 84 calculator, there's something that you have to do to your calculator first, and you only have to do this once. You have to do something first on these calculators to get it to show you all the information you need. And it's known as a diagnostic. If you've got a Casio, you don't have to worry about that. It's dying. Okay. So, this first set of instructions is just for those of you who have TIs. So we have to turn the diagnostic on these calculators. That's the only way the calculator is actually going to tell me what the correlation coefficient is. Look at your 0 button on your TI-83 or TI-84. Do you notice that right above it, it has the word catalog? The catalog tells me everything the calculator is capable of doing. We need to go into that catalog. Now, if it's one of these upwards buttons, in my case is blue, what do I have to hit to get into that? The second. And then 0 will bring me into the catalog. And it tells me everything that it can do. It can do absolute value, ands, it can deal with angles, ANOVA, which I have no clue what it is. You are going to scroll until you get to the D's. Literally just hold the down button. It's going to be a bit. And you are going to look for diagnostic on. Once you have found it, make sure your cursor is on it, click enter, and click enter again. It will say diagnostic on, done. That is the thing you have to do once. You'll never have to do it again. We just have to do it. Anyone with a TI not find diagnostic? Sweet. Okay, now let's get to the actual working with data. So we are, by the way, here, given something that is correlated, or in theory correlated. Yes? That's because you got a Casio. You don't have to change from a Casio. We're going to do it on Casios too. TIs are just the only one you have to do this on. The first set of instructions was only about TIs, that's all. Okay, so we are going to deal with something that does have a correlation. The length of your femur and your height are considered correlated. Okay, so I want to work with this set of data. The first thing I have to do is I have to get data put into the calculator. To do that, I have to go into the statistics menu. On a TI calculator, you'll see the button, it says stat. That's the statistics menu for the TI. Click it. On the Casios, you will not find a stat button. On the Casios, to get into your statistics menu, you have to go back to your main menu that tells you all the things that the Casio does. So I click menu. Now this Casio and the yellow Casios are set up a tiny bit different on this menu, but generally speaking, you should find either stat or statistics as the second option. Scroll over to it using your arrows, and then once statistic is there, click enter. Are we having issues with the calculators? Got one that does? No, I don't think all the prisms actually have batteries. Okay, so now I'm in my statistics menu. Now in my statistics menu, I need to get to the place where I can enter data. The Casio, as soon as you're in the statistics menu, it gives you these tables that you can put data into. The TI, you have to get into that. You have to take one more step, and you have to go into edit. So click enter, because edit should already be highlighted. Both calculators should now have a list. Now, you'll notice that both of my calculators have numbers in that list. Some of yours might, some of yours might not. We need to get rid of that information out of it. Put the phone away before it's mine. So, to get rid of that data that's already in there, be careful on your TI, because the TI, you could screw up the calculator. Easiest way to do it, especially if it's a longer list, is go up to the list's name and click clear. Has to be the clear button. Do not click delete or you're going to screw up your calculator. Click clear. It's not going to do anything at first, but once you click enter, it clears out the entire list. Do that with each of your lists that has numbers in it. On the Casio, if you've got any data in there, to clear out your lists, your main menus goes along the bottom of your screen. You use F1 through F6 to get to it. Use F6 to scroll over. And you'll see a del and a del all, or a delete and a del all. Del all will delete an entire list. It'll ask, are you sure? Yes, I'm sure. Get rid of the data in your lists. From here, you are going to type the data into our lists. X is always going to go into L1, Y is going to go into L2, and make sure if 40 is the first number you type into the first list, 170 has to be the first number you type into the second list. The lists right next to one another need to be kind of like this table. So type in the number 40, click either enter, and click enter, it'll go down and let you type in the next number. The Y's go into list 2. Does everyone have their data in their lists? Okay. At this point, we can do a couple things. One thing we can do is we can view the data. You can actually look at what the graph looks like. It tells you if there is a linear relationship or not by looking at the graph. In ones like these ones, yes, there's a linear relationship. And if it looks like that, there's not a linear relationship. So, to do that, I'm going to go with Casio's first. Looking at your bottom menu, you need to find where it says graph. So use F6 to scroll over to where it says graph. Should be the first one there, once you find it. Now, there are a bunch of different style graphs here. They're set up however the heck the last person who used the graphing on the calculator set them up. So we got to set it up first on the Casio. So you're going to go into set on the far right, and that's going to set up what type of graph you're going to do. On the TI, you're going to have to do similar in idea. To get to yours, right below your screen, do you see where it says stat plot? You need to go into that. Note it's a secondary button, so you click second and then that. This is going to be something you don't have to set up very often. Now we are going to set plot 1 or graph 1, depending upon which type of calculator you have, as a scatter plot. So on the Casio, I want to edit graph 1. On the TI, I want to edit plot 1. So I'm going to click enter and it's going to bring me in. The Casio technically was already there. First thing I'm going to do, on the TI, I'm going to turn it on. And then when I scroll down to type, I want to pick the scatter plot. Which one looks like the scatter plot? Yeah, first one. I'm going to scroll down. I'm going to click enter on that. On the Casio, I'm going to go down to graph type. And on the bottom left of your screen, it should give you an option of changing it to a scatter plot. Click that. Both calculators then ask, what do you want the X list to be and what do you want the Y list to be? We want them to say list 1 and list 2. Most of your calculators will already say that. If it doesn't, you can change it. Don't worry about the frequency or the mark type or the color length or any of that. Once you've got this set up, you're good. On the Casio, you can click exit. On the TI, you can click clear. Oh, maybe not clear. It won't let me clear. Sorry, I thought clear got us out of that. Okay, you can go to quit. Do you see quit right here on your mode button? Second, quit. Okay. On my Casio, it now brought me back to my graphing menu. And all I literally have to do now, as I set up graph 1 to be a scatter plot, is click graph 1. And it'll show me a scatter plot. On the TI, it exited out of my statistics menu, but that's okay. On your TI, you can click graph. Now, do you notice my TI gave me some parabolas, some U-shaped graphs? It's because I have some things typed into my TIs. In your TI, if you have anything showing up here or an error, go into Y equals and get rid of all the things that are there. Go through, clear them all out, then try clicking graph again. Notice how I see nothing? It's because the TI, you have to tell it what to look at. The Casio does that work for you. On the TI, if you click zoom, it'll give you options on what to zoom in on. We're going to zoom in on some statistics, so we're going to do the 9. Now it shows me a scatter plot as well. Looking at that scatter plot, does it look like it forms somewhat of a line? Yeah, it shows somewhat of a line, and it looks like it's a positive correlation, and it looks like a fairly strong one. So, it is forming a linear relationship. The question asks, does the data show a linear relationship? Is it forming a line, in other words? So you look at the graph to see that. Does it form a linear relationship? Yes. And for the sake of our notes, I'm going to write a little bit more. When plotted, it looks like a line. That way, in the future, when you look at your notes and you're like, wait, how did I know it was a linear relationship? That's how. Because you plotted it and it looked like a line. If so, write an equation for the line of fit. and use it to estimate the height of a person that is 35 centimeters long. Now, without a calculator, you can write a line of fit. You can plot a bunch of points to make the scatter plot even. If you are doing this without a calculator, you grab 2 points on this and you find the slope and you plug it into point slope form and then you move it into slope intercept form. You do what we've already done twice so far this trimester with writing equations. If you're doing it with a calculator, you're going to go back into your statistics menu. On the TI, I click stat. On the Casio, if I click exit, it brings me right back to my statistics menu. Now, I've currently got my graphing menu up on the Casio, and I want to get back out of that, so I'm going to click exit one more time, and it's going to change that bottom thing. If I want to write the equation, I want to calculate the equation. Do you see on both calculators where it says calc? It's a calculate menu. Scroll over to it. On the Casio, you're not scrolling, you're just clicking calc. It gives you a lot of options on this one. Fewer options on this one, but that's okay. What we want is ln reg ax plus b. For the equation, note to self, we want ln reg ax plus b. For the TI, that means clicking the fourth option. For the Casio, click reg. Now it asks me, do I want an x regression, a median regression, an x squared, an x cubed, an x to the fourth? Which of those is linear? Regular x's. So I click x, and then there's ax plus b. Now my Casio goes automatically to doing the calculating. My TI asks me, do you have your x values in list 1 and your y values in list 2? Is that where we put them? Yes. We didn't do a frequency list. We don't need to store it. We just scroll down and tell it, yes, please calculate it. If you have a TI-83, it shows up on your screen as ln reg ax plus b. You got it easier. Click enter. Mine's going to say invalid dimension because I don't have any data in there. But if you got the TI-83, it's easier. You literally, ln reg shows up, click enter. Yes, please do ln reg. Notice what your screen shows you. It shows you an A, a B, an R squared. This one has an MSE. Don't ask me what it is. I don't know what it means. I've never used it in my life. And then do you notice that at the bottom of your Casio, or at the top of your Casio, it shows you y equals ax plus b? In other words, it's telling you what your equation is. It's telling us our equation is y equals, what does it say A is? About 2.6. I would go to 2 decimal places. In this case, it's 2.60. Didn't do anything, but in the future, use 2 decimal places. Then it goes x, because that's ax, plus, what does it say b is? If I'm rounded to 2 decimal places, 65. That's my equation. Do you notice that it also says r? It's the 3rd option on my Casio, the 4th option there. That's my correlation coefficient. Correlation coefficients, keep them to 2 decimals. 0.99. If r is 0.99, what do you know about that regression? It's really, really close to 1, which means it's really, really positive and strong positive. The closer to 1, the stronger. The closer to -1, the stronger negative. didn't we already kind of know that by looking at the scatter plot? Yeah. So, does the data show a linear relationship? Yep, we could tell by the plot. If so, write an equation for the line of fit. Sweet, we just did that. Use it to estimate the height of the person with a femur that is 35 inches long. Sorry, centimeters. 35 centimeters long is the length of the femur. Is that an X or a Y value? X. I'm asking you, if X equals 35, what is Y? How do you find it? You plug it in. Y equals 2.60 times 35 plus 65. Now the thing that kind of sucks about the Casio at this point is that if you want to plug that in and you want to use your Casio calculator, you got to go back to your main menu and back to your run matrix to get back to your regular calculator, which means you have to be able to go back and forth between the menus. But it works in the end. Y equals 156. And that's measured in centimeters. These are the three things it asked. Yes, it's linear. Here's the equation. Here is the estimation. Again, if you have a situation where you do not have a calculator, you can grab any 2 points, use y2 minus y1 over x2 minus x1 to find the slope, and then use the point slope form to write the equation. I know not all of you have graphing calculators, but you can use this. The only other thing it might ask you to do is stuff like this. Use the technology to find the equation for the line of best fit, identify, interpret the correlation coefficient. We're not going to do this entire problem. We're just going to talk about how to do it. First thing I have to do is, do you notice there's some coordinate points here? I have to plug them in. Now, one of the things I've noticed is some of y'all struggle with coordinate points. When you're doing coordinate points, do you do left, right first or up, down first? Left, right. If you're going to the right, is it positive or negative? Negative. You're moving to the right, positive. You're moving to the left, negative. Then you do up, down second. Up is positive, down is question. Here's one of the most common things that there seems to be a hiccup on. If the first one's positive, does that guarantee the second term that the y is positive, in other words? No. For some reason, the people, the moment that they see, oh, it's positive 3, and then they just assume that the next one's positive. Or it's negative, so they assume the next one's negative. No. What are the coordinates of this point? How much left, right did it do? 0, comma, how much up, down? 30. How about that point? 125. This point? 220. That one? 310. And then this one? 4, 5. You would plug those points in, you would do all the work. Now it asks to identify and interpret the correlation coefficient. What that means is to solve for R, figure out what it is, and then interpret the correlation coefficient. In other words, tell me, is it a strong positive, a strong negative, a weak positive, a weak negative, or no correlation? Could you probably interpret it by looking at the graph itself? Yeah. So again, if you don't have a graphing calculator, can you tell me exactly what R is? No. I couldn't even tell you what the formula for R is. It's complicated. Could you tell me it's a strong negative correlation? Yes. You're not without information, but that's the interpretation. Okay, I'm going to stop right there. We're going to move on to homework. on page 24, day 2, and it is numbers 11 through 19, but only the odd problems. So, speaking of correlation, one of the things I plan to do is I plan to hand back your guys' quiz today. Overall, the quizzes showed up fairly well like I expected because there is a correlation between